Welcome to This Explainer. Today we're going on an incredible journey. We're going to zoom way out to look at this massive, macro-scale intelligence explosion happening all around us right now. Then we'll shrink right down, literally diving into the mathematical engine room of artificial intelligence to see exactly how these systems actually think. Finally, we'll zoom back out to see how all this technology is completely rewriting our real world. It's a wildly fascinating ride, so let's get into it. Okay, here's our roadmap for today. We'll kick things off with the intelligence explosion, move into how neural networks think, check out the generative AI revolution, the rise of AI agents, how they're disrupting film and tourism, and finally wrap up with the dangers and the singularity. Section 1. The intelligence explosion. Now, the absolute most crucial thing to wrap your head around here is that AI's growth hasn't been some slow, straight line. For decades, it was barely at the intelligence level of a bird, but then it went exponential. Somewhere right around 2023 to 2026, it actually shot right past human-level intelligence. To put this sprint into perspective, we started way back in 1950 with Alan Turing's famous test to see if a machine could fool a human. Decades went by with kind of slow progress, right? Until 2012 gave us AlexNet, a massive leap in image recognition. Then, boom, 2017 hits us with the breakthrough transformer architecture. By 2022, ChatGPT 3.5 makes AI completely mainstream. And fast forward to 2025, we're dealing with fully autonomous AI agents. It is just a staggering acceleration. And what this really shows us is that we are in the middle of a massive transition. We're moving away from artificial narrow intelligence, machines that specialize in just one specific thing, like playing chess, toward artificial general intelligence. But the ultimate destination? That's artificial superintelligence, or ASI. We're talking about an intellect that's smarter than the absolute best human in practically every single field, triggering what thinkers call the singularity. It's the point where AI can just recursively improve itself, and beyond that, things become totally unpredictable. Actually, as the course professor for our source material jokingly points out, at that stage we can really only hope an ASI doesn't hold any grudges against its creators.
So what's throwing gas on this fire? Data. Specifically, an estimated 181 zettabytes of data generated globally in 2025 alone. This near-vertical spike in data creation is the literal fuel training these AI systems. Simply put, more data directly equals smarter AI.
Section 2. How neural networks think. But how does this machine actually think? What is it doing with all that data? Well, to figure that out, we got to look at where the inspiration came from. Our own brains. Think about our biological brain. It's packed with about 100,000 billion synapses, and memories distributed everywhere, kind of like a giant hologram. Now, compare that to the artificial neural network, which tries to mimic this using math. Instead of biological synapses, it uses what we call parameters, or weights. But unlike our super messy organic brains, these artificial networks are neatly organized into rigid input layers, hidden layers where the actual thinking happens, and output layers. When you or I learn something, our synapses physically strengthen. That's synaptic plasticity. In an artificial network, the machine learns by just tweaking the numerical weights that connect its nodes.
But wait, how does it know how to adjust those weights in the first place? That brings us to one of the most absolutely crucial concepts in AI, backpropagation. This is the training algorithm. It figures out the errors in a model's prediction and then literally sends that error data backwards through the network to fix the parameter weights. This is how the machine actually learns from its mistakes, instead of just following rules hard-coded by a programmer.
Let's walk through exactly how this happens, step by step. First, the machine starts out with totally random weights. Second, it takes a guess, makes a prediction. We call that a forward pass. Third, it measures how wrong that guess was using something called a loss function. And fourth, it adjusts those weights backwards so it does a better job next time. It's really just like a parent teaching a child to speak through supervised learning. If the kid says the wrong word, you gently correct them. Imagine doing that billions of times across mountains of text. Eventually, the AI develops these incredible emergent properties. It learns the hidden structure of human language so well that it can suddenly translate, write code, or summarize, even though its only actual job was just to predict the very next word. Section 3. The generative AI revolution. Building off that foundation of neural networks, we hit an era where deep learning models can create entirely new content. Now, what's really interesting here is the sheer scale of parameter growth. It's a massive leap. Back in 2018, GPT-1 had 117 million parameters, and Honestly, it would just loop nonsense if you asked it a question. But by ChatGPT 3.5, we hit 175 billion, and with ChatGPT 4T, a staggering 1.7 trillion parameters. This colossal jump in scale was exactly what solved the AI's ability to actually give us coherent, nuanced answers. Scale really matters here. Way more parameters mean vastly better pattern recognition. But, scale alone wasn't going to cut it because human language is incredibly tricky. Take this sentence, for example. The animal didn't cross the street because it was too tired. Now, if you're a machine, how on earth do you know if the word it means the animal or the street? We humans get it instantly, from context. But for the longest time, AI models were completely stumped by this kind of ambiguity. So how did they crack the code? Well, in 2017, a landmark paper called Attention is All You Need dropped, introducing the attention mechanism. Basically, instead of just reading dictionary definitions, the AI translates words into massive lists of numbers called embeddings. It then updates those numbers based on the surrounding context of the entire text. Think of it like reading a detective novel. By the time you reach the final chapter, the AI has used this attention mechanism to mathematically calculate the exact probability of who the assassin is. The math behind the verb to be literally updates to hold the probabilities, like John is the killer at 25%, Mary at 18%, and so on. It is literally context encoded as math, and it's exactly what finally let AI understand human context.
Section 4. Rise of AI agents. Having that kind of context awareness totally changed the game, shifting us from AI that just talks to AI that acts. Let's see how this builds up. First, we had large language models that just generated text. Then came answer engines connected to the web. Then multimodal AI that could actually see and hear. Following that, reasoning models that could think through problems step by step. And finally, by 2025, we hit step 5, AI agents. This is where AI finally gained true autonomy.
I can't overstate this. AI agents are a huge deal. They can perceive their environment, like reading whatever is on your screen. They make autonomous decisions, and most importantly, they can take actions via APIs. That means they can click, type, and make payments without you holding their hand step by step. For example, an agent like OpenClaw can literally clean out your inbox or book your flights entirely on its own through WhatsApp. It is fundamentally changing how we interact with the digital world, basically handing you back hours of your day by taking over all those mundane tasks.
Section 5. Disrupting film and tourism.
So what actually happens when these autonomous agents are let loose in the real world? Well, in the tourism industry, the impact is profound. You don't need to search through dozens of booking sites anymore. You just talk to a personal agent naturally, and it builds and books the whole trip for you via APIs. Meanwhile, hotels are running sentiment analysis to instantly spot trends hidden in thousands of customer reviews. And crucially, agents are taking over back-office automation, handling CRM and billing, which actually frees up human staff to get back to what they do best: genuine, empathetic, face-to-face hospitality.
Over in Hollywood, the disruption is just as wild. Production costs have already been slashed by 20 to 50%, all thanks to incredible AI video tools like Veo and Sora. You'll see AI acting as this amazing brainstorming assistant for screenwriters, and tools are practically taking over the logistical heavy lifting of producers. But here's the catch. While AI can pre-visualize these absolutely stunning shots, it really struggles with emotional subtext, and it definitely cannot direct human actors. The machine handles the technical execution, sure, but humans firmly hold on to the emotional and artistic vision. Across pretty much all industries, this shift is leading to what thinkers are calling the SaaS apocalypse. Because AI agents can just perform tasks directly. Traditional cloud-based software, all those apps we pay monthly subscriptions for, are suddenly facing obsolescence. AI is rapidly becoming this invisible infrastructure, kind of like electricity. It's just there, quietly powering everything in the background.
Section 6. Dangers and the singularity.
Now look, any technology this insanely powerful obviously comes with massive risks. Thinkers and technologists are super divided on this. But Roman Yampolsky, the guy who actually coined the term AI safety, frames the existential threat perfectly. He says, imagining humans can control super-intelligent AI is a little like imagining that an ant can control the outcome of a football game being played around it. I mean, wow. It just perfectly captures how incredibly difficult it will be to control something that is fundamentally, exponentially smarter than we are.
And that brings us right to the core issue of all this: value alignment. The source material uses this brilliant Superman analogy that I just love. Imagine raising Superman, an alien with totally unimaginable power. If you raise him with good human values, you get an aligned AI. You get a superpowered hero who helps humanity. But if Superman is raised with bad values or trained on bad data that reflects a heavily biased worldview, you get a misaligned AI, a highly destructive supervillain. The training data and the values we are feeding into these models right now will literally determine which version of Superman we end up with.
Which leaves us with the ultimate question. As we hurtle toward the singularity, that point where AI will recursively improve itself completely beyond our comprehension, are we raising a profoundly helpful tool for humanity or an uncontrollable Superman? It's a heavy question, but it demands our attention as we keep building this incredible future. Thank you so much for joining me on this explainer. Keep learning, and I'll see you next time.